Let's look at another 1D kinematics problem. Let's have a car accelerating at 2.50 meters per second squared from an original speed of 7.5 meters per second to a final speed of 30 meters per second. Now for context, 2.5 meters per second squared is roughly a quarter g, so you will feel this. This is a series acceleration from a car with a large engine. 7.5 meters per second is about 17 miles per hour, and 30 meters per second is 67 miles an hour. So this would sort of be a highway entrance from almost standing still. 17 miles an hour is really slow to be entering a highway initially at. So we start out with original velocity, we end up with a final velocity sometime later. So the first thing you want to do before you even take a look at any question that is being asked is make your VOFA style list and read the story again and pull out from the story these numbers, and you need to notice that there are three numbers. There will always be three numbers in 1D kinematics problems. First one is the acceleration, accelerates at, and there are two clues here, the word accelerates and then the units. So that 2.50 will come down here to A. Then we have an original speed, so that will be VO. And we will have a final speed. Again, clues are in the units as well as in the language used. So you need to actually read these words. If you notice, I've now underlined almost the entire story. The car is just for flavoring context, and we could, if we were going to depend entirely on the units and context clues, we could take out the word accelerates here. A car, accelerates at, car moves faster at. I could disguise accelerates by getting rid of accelerates and using a different synonym, but then you really have to look at the units. And I could also get rid of the word original and the word final. And then we rely on the English context skills of from and to. So a car moves faster at this from a speed of 7.5 to a speed of 30. Notice how the meaning has stayed the same, but I've taken away some of the verbal context clues so that you have to rely more on your implicit understandings from English class. Now, what are the questions that I can ask you? I can ask you, how far does the car go in this time, and how much time does it take? So, for part A, we can say calculate how much time it takes the car to accelerate. Well, we have VO, we have VF, we have A, and for part A, I'm asking how much time. So I'm asking for time, and we will use the equation that doesn't have the S in it, so our no S equation. So VF equals VO plus AT. And we have 30 equals 7.5 plus 2.5t. Rules of algebra say if you want to move something from the right to the left, you have to subtract it. If you were adding it before, so you do the opposite. Right now we have a plus 7.5, the plus is implicit, and we subtract it to get it to move. And the second rule of algebra is you're allowed to do anything you want as long as you do the same thing to both sides. So since we're going to subtract 7.5 from the right, we have to subtract 7.5 from the left. So 30 minus 7.5 is going to get us 22.5. 22.5 equals 2.5t. Now again, if you want to move something from the right to the left, you have to do the opposite of the operation that is currently written. So the operation between 2.5 is t is multiply, and so we divide, and then we do the same exact thing to the other side of the equation, and we end up with 9.00 seconds. I gave you three significant figures, three significant figures, three significant figures, so then at the very end, let's have three significant figures. All right, for part B, Then I will write at the bottom, and then I will do my work over on the right. Now that we have the time, let's get the distance. How far does the car go in this time? Now that we have the time, we can use it if we want to. We can also use the equation that doesn't have the time. You can use any equation that you want that includes s in the equation. So let's use this one just because I like it. There are others that you could use. The final speed is 30. The original speed is 7.5. We're accelerating at 2.5 meters per second squared for a certain amount of distance. So squaring these guys is going to get us 900. Squaring 7.5 is going to get us 56.25. Multiplying 2 and 2.5 is going to get us 5. And if you notice, this equation now has the same form with the numbers as the previous equation did with the numbers. So we have a number equals a number plus a number times our variable. So the first thing we're going to do is subtract the number because we want to get the variable by itself. And that will cancel the number on the right. And what we have is 900 minus 56.25 gets us 843.75 equals 5s. And now we will divide both sides by 5. And that will get us a distance of 168.75 meters. Again, 3 significant figures given to you at the beginning. You need to have 3 at the end, so that will round to 169 meters, or roughly, not quite, 2 football fields. That's about how long it would take this car to accelerate up on the highway from that speed, and it would take 9 seconds.